Our final topic for section 8.4 deals with finding the roots of complex numbers. We have a formula that will give the roots of complex numbers. And as we saw in the last presentation, we have two versions of this formula, and it would be fine and acceptable to use either version when you're asked to work a problem. So we have this version, which is a little bit longer, and we have this version. And again, once we look at an example, these formulas become a little bit easier to work with. So let's go ahead and take a look at what our example is going to look like. So our example says, find all the fifth roots of 1 and graph their location in the complex plane. Okay, so what we're going to do first of all is we're going to take this 1 and we're going to write it as a complex number. So 1 is the real part, and the imaginary part had to have been 0i. And we want to think about it that way so that we can identify the angle a little bit easier. So we want to realize that this 1 that we are given can be written as a complex number if it looks like this. Okay, so with that said, I need to calculate two things in order to use my formula. I need to calculate my magnitude, which again is going to be the square root of a squared plus b squared. So we're going to have the square root of 1 squared plus 0 squared, which is going to give me 1 plus 0. Which is going to give me the square root of 1, which is equal to 1. So we know that the magnitude is equal to 1. All right, now let's find our angle. We know that we can use the formula tangent theta is equal to b over a for our angle. We'll plug in our b value, which is 0, and our a value, which is 1. And so we're looking for an angle that has a tangent value of 0. And so we know that that is equal to 0. We know that inverse tangent of 0 is equal to 0. Okay, so with that said, let's go ahead and write our formula down and start plugging our values in. Now I'm going to use, for this problem, the more simplified version of the formula, which is this part at the bottom. And I'm going to jot it down on the next slide for us so that we can reference that. So our formula is going to say WK is equal to the magnitude of z raised to the 1 over n power times e to the I. And then we're going to have theta plus 2k pi over n. Okay, so let's start plugging in. Now we're going to find 5 roots for this complex number. All right, so we're starting with the first one. We're going to put our magnitude in, which we said was 1. We're going to raise it to the 1 over n, and n is going to be 5 since we're looking for fifth roots. Then I'm going to have e to the I. We're going to use our angle theta, which is 0, plus 2k, and recall that our k starts with 0. We use 0 as the first k value. All right, so I'm going back over here and I'm going to plug 0 in for my k. Pi over n, and remember that n again is 5 because we're talking about a fifth root. So if we look at what's happening on the top part of that fraction, 0 plus 2 times 0 pi is still going to be 0. So we have 0 over 5. All right, so I have 1 to the 1 over 5 times e, and this fraction simplifies to 0, and 0 times I is also 0. And so we know that anything raised to the 0 power is 1. So I have 1 to the 1/5 times 1. 1 to the 1/5 is just 1. So our first fifth root is going to equal 1. All right, let's go ahead and find the second one. All right, so for our second one, we're going to use our magnitude, which is 1 to the 1/5 power again. We're going to have e to the I. We're going to have an angle 0 plus 2 times this time 1 pi over 5. 1 to the 1/5 is 1. On the top part of our fraction, we have 0 plus 2 pi, so we just have 2 pi over 5. And so our next root is going to be e raised to the I times 2 pi over 5. Okay, let's move on to the third one. So for the third one, we're going to have a very similar setup. The only thing that's going to be different is that instead of using a 1 for the k value, I'm now going to use a 2 right here. Again, 1 to the 1/5 is 1. We have e to the I. On the top part of the fraction, we have 4 pi, and on the bottom we have 5. And so our next root will be e raised to the I times 4 pi over 5. Moving on to the next one. Again, 1 to the 1/5, e to the I. On the top, we're doing 0 plus 2. Now the k value is 3 times pi over 5. So 1 to the 1/5 is 1, e to the I, and our fraction becomes 6 pi over 5. And this is our fourth root. And our final one, we'll take 1 to the 1/5, e to the I. We'll use a 4 for the k value, which is going to give us e to the I. And on the top, we'll have 8 pi over 5. And this will be our fifth root. The other thing that we're asked to do on this problem is to graph the locations of these 5 roots in the complex plane. And you can see that that is done here. And so remember that in order to do this, you are going to draw each individual angle. So for example, if I were going to look at this one, for example, I would need to draw an angle at 2 pi over 5. Now, what you may need to do with 2 pi over 5, since it is not a definite angle, is you may need to convert it to degrees so that you can see a little bit better where that angle actually lies. That angle is 72 degrees when I convert it to degrees. All right, so I'm just going to make myself a note over here. And all we did, remember, is multiply by 180 over pi. And that's going to give me 72 degrees. So I can come here and I can plot an angle that is roughly 72 degrees. And then remember that your magnitude, the distance from your 0, 0 point to the point that you're plotting should be 1 for this particular problem. Remember that we calculated that magnitude to be 1. And so we'll go out a distance of 1 and place our point. And you can do the same thing for all 5 of those points. All right, and you see that those points are evenly spaced around a circle of radius 1. Okay, we're going to look at one other example. We're being asked in this example to find the fourth roots, and our problem is -1 minus I on the square root of 3. So again, we're going to begin by finding our magnitude and our angle. So let's work on the magnitude first. So our magnitude formula is the square root of a squared plus b squared. So I'm plugging in my a and my b values. -1 squared is 1. The square root of 3 squared is 3. Adding them together, we get a magnitude of 2. All right, let's find our angle. So for our angle, we'll say tangent theta is b over a. So I'm going to have negative square root of 3 over -1, which will be positive square root of 3. Now again, we know that tangent is positive in the first and the third. And we know that in the first quadrant, it is equal to square root of 3 at pi over 3 or 60 degrees. Let's check and make sure that we need to be in the first quadrant. So if I come back to my original complex number and plot it, we're going to go over -1, and then we're going to go down negative square root of 3. And so our point's going to lie actually in the third quadrant. And so we need to move that pi over 3 to the third quadrant. We know that the corresponding angle in the third quadrant would be 4 pi over 3. And so that is the angle that we're going to be using. All right, so we have our magnitude and we have our angle. Let's go ahead and plug into our formula. And again, I'm going to use the same version of that formula, the one that looks like this. And we're going to do it 4 times to find the 4 roots. All right, so we're going to take our magnitude, which is 2. We're going to raise it to the 1/4 power. Remember, using 4 because we're looking for the 4th roots. Then we're going to say e to the I. We're going to plug in our angle, which is 4 pi over 3. We're going to add 2. The k starts with 0. And we're going to divide by 4. All right, so 2 to the 1/4 I'm going to leave alone for right now. And I'm going to go inside this parenthesis and simplify. Now, this 2, 0 pi just kind of cancels out because that's going to become 0. So really we're looking at 4 pi over 3 divided by 4, which is the same thing as multiplying by that reciprocal. And when I do that, these 4's are going to cancel, leaving me pi over 3 inside that parenthesis. All right, and so this is my first root for that complex number. Now, 2 to the 1/4 doesn't end up being a nice whole number, so we're going to just leave it as 2 to the 1/4. Okay, so let's move on and look at our second root here. So for our second root, we're going to do 2 to the 1/4. Everything is going to stay the same, except we're now going to put a 1 in for the k. And we're going to work at simplifying. Okay, so let's work inside that parenthesis for just a minute off to the side. So I have 4 pi over 3, and I'm going to add 2 pi to it. So adding 2 pi is the same thing as adding 6 pi over 3. Now make sure that that makes sense to you. 6 over 3 is the same thing as 2. And now that I have the same denominators, I can add them together. 6 and 4 make 10 pi over 3. And we're taking that number, that's just the top part of this fraction, we're taking that number and dividing by 4, which we know is the same thing as multiplying by 1/4. So I'm going to get 10 pi over 12, which is going to reduce to 5 pi over 6. So lots of algebra skills playing into that simplification there. All right, so my final answer here is going to look like this for the second root. All right, let's go ahead and move on to our third root. So we have 2 to the 1/4, we have e to the I, we have 4 pi over 3, we're going to increase the k value to 2, and divide by 4. And again, I'm going to off to the side somewhere work on what's in those parentheses. So I have 4 pi over 3, and I want to add 2 times 2 is 4 pi. So 4 pi over 3, we're going to add 12 pi over 3. And again, 12 over 3 is the same thing as 4. So when we add that, we're going to get 16 pi over 3. When we divide by 4, it's the same thing as multiplying by 1/4. So we're going to end up with 16 pi over 12, which is going to reduce to 4 pi over 3. And so now I can plug that in, 2 to the 1/4, e to the I, and my angle will be 4 pi over 3. And this will be the third root for that complex number. All right, and we have one more. So we have 2 to the 1/4, we have e, 4 pi over 3, plus 2 times 3 this time, pi, over 4. All right, let's work on what's inside the parenthesis. I'm going to have 4 pi over 3 plus 6 pi. 2 times 3 is 6. We're going to rewrite 6 pi with a denominator of 3, so it would be 18 over 3. 18 over 3 is the same thing as 6. 18 plus 4 is 22. So we have 22 pi over 3, and then we're going to divide by 4, which is the same thing as multiplying by 1/4. So I have 22 pi over 12, which is going to reduce to 11 pi over 6. And so we now have our fourth root, which will look like this.